Hello everyone. So today's topic is Fresnel's diffraction. Before going to the Fresnel's diffraction, we will know about what is meant by Fresnel's off-period zones. Okay. Uh, After that, we will go into the Fresnel's diffraction pattern topics. Before that, here you see a word wavefront. So how many kinds of wavefronts are there? There are total 3 kinds of wavefronts. Okay. I'll just okay, if there is a point source, what kind of wavefront you will get? You will get always a spherical wavefront. Okay, it's something like spherical wavefront. If the point source is placed at infinite distance, okay, it is at infinite distance, what kind of wavefronts you will get? You will get a planar wavefronts. Okay, planar wavefronts. So when point source is at infinite distance, you will get a planar wavefront. If there is a linear source, what kind of wavefronts you will get? If the source is something like linear, what kind of wavefronts you will get? You will get cylindrical wavefronts. Okay. Just remember these things. Okay. Point source, you will get spherical wavefronts. Point source placed at infinite distance, you will get a planar wavefront. If there is a linear source, you will get a cylindrical wavefront. Okay. What Fresnels did is he he took the planar wavefront, okay, and he divided into the wavefront into the number of zones. This is one strip. Number of strips or number of zones. One strip, second zone, third zone, fourth zone. So he divided complete wavefront into the number of strips or number of zones. Each zone is called Fresnel's zone. Okay, this is first zone, second zone, third zone, fourth zone, fifth zone, like that. 10 zones are there. These zones are called Fresnel off-period zones. Off-period means, you see the name itself tells you, period means time period T, off means 2, T by 2. So any zones, if you consider first zone and second zone, their time period difference is T by 2. If you take second zone and third zone, the time period difference is T by 2. If there is a T by 2 difference, there will be a path difference lambda by 2. Okay, off. So first zone, second zone difference, path difference is lambda by 2. Similarly, second zone, third zone, path difference is lambda by 2. So similarly, every zone is differed by its neighbor zone by a path difference lambda by 2. Path difference lambda by 2 and the phase difference will be also pi difference. Okay, so this point is very important. Off-period zones, the zones differ from its neighbor, like first and second, second and third, third and fourth. Each zone differ by a phase difference pi and path difference lambda by 2 and time period t by 2. That's why these zones are all called Fresnel's off-period zones. Okay, off-period means time period t by 2, lambda, path difference lambda by 2, phase difference pi. The more elaborate way I have written here, a Fresnel's off-period zone with respect to an actual point. So this is a planar wavefront. Okay, at point P, out away from the planar wavefront. So this zone is a thin annular zone. Okay, with respect to point P. Okay. The Fresnel off-period zone is a annular zone. Annular means circular zone of primary wave. This is a primary wavefront. On that there is a circular zone. Okay, from which you will get a secondary waves. From this zone, any wave is coming means that is a secondary wave. Okay, so the zone and first zone and second zone will be differed by path difference lambda by 2. Similarly, second and the third zone will be differed by path difference lambda by 2. So neighboring zones will differ by path difference of lambda by 2. Okay, so if they ask what is Fresnel's off-period zone, you can just write this statement. A Fresnel off-period zone is an thin annular zone of primary wavefront in which secondary waves from any two corresponding points of neighboring zones differ by path difference lambda by 2. Okay. Now, since it is a annular zone, they will have a radius and area of the off period zones. I want to find what is the radius of the Fresnel off period zones and the area of the Fresnel's off period zones. Okay. So I want to find the what is the radius of the first off period zone and what is the area of the first off period zone. Similarly, what is the area of the second off period zone, and similarly I want to find the nth off period zone radius and area. Okay, to do that, what I consider is ABCD is a planar wavefront and P is an external point. This is an external point, okay, from planar wavefront. So Fresnel's treatment is always something like you divide the planar wavefront into the number of zones. So I'm just taking actually to be if you consider a point P which is away from the planar wavefront, external point, okay, and you construct some spheres. Sphere is 3D, okay, whose radius is B, okay, initially, and second sphere whose radius is B plus lambda by 2, okay, B plus lambda by 2, B plus lambda by 2, and third sphere, it's a 3D diagram, okay, B plus 2 lambda by 2, okay, and similarly uh, third sphere B plus 3 lambda by 2, and fourth sphere B plus 4 lambda by 2. So all these are in 3D diagram. So when it touches any planar wavefront, okay, a planar wavefront, you will see something like circular zones, okay, circular strips. So that's what here. This is a planar wavefront. On that, first half period zone is this one. Second half period zone is third half period zone. So we want to find what is the radius and what is the area of the uh, zones. Okay. For that, the basic point is you should remember is as I said, the front off period zones they differ by path difference lambda by 2 and phase difference. This is very fundamental point. You should remember always. Fresnel off period zones means any two zones will differ by path difference lambda by 2 or phase difference pi. Okay. Now in this I want to find what is the radius of the first zone. You see here the OM1 is the OM1 is the radius of the first half period zone. Similarly, OM2, the second circle. OM2 is the radius of the second zone. OM3 from center to M3, third half period zone radius. OM4, similarly, OMN. There will be nth zone. I want to find the radius of the nth zone, OM1. Okay. So first I will find out the OM radius of the first zone. You see here, since it is this is OM1, okay, and there is point P here, which is at a distance B. Okay, it's a right angle triangle, and this is B plus lambda by 2. Okay. So what you will get using the Pythagoras theorem. Pythagoras theorem, OM1 square hypotenuse square B plus lambda by 2 whole square equal to B square plus OM1 I consider R1, okay, R1 square, okay. So same thing I have written here. If you see here, to find out the R1, what I considered is I just considered the Pythagoras theorem, and R1 square I found out using the Pythagoras theorem. So this is the R1 you will get, R1 square, okay, R1 square. So area of the first half period zone, if you know the radius of the circle, you can find out the area pi r1 square. So substitute r1 square value here. You will get final expression as this one, area of the pi lambda b plus pi lambda square by 4. Okay. Since lambda is very small value, okay, lambda square term will be neglected. Why it is neglected? Any idea? Since lambda value is very small, so let's take lambda value as 0.01. So what happens to the lambda square? 0.0001. Okay. So as compared to the 0.01 value, it is very small value. So here lambda square term will be automatically neglected. So area is finally become A is equal to pi lambda b. Okay. So this is the area of the first half period zone. Now what since this is area is equal to pi r square 1. Okay. So pi get will cancel. So r1 you will get as root b lambda. Okay. Now I want to find what is the radius of the second half period zone and what is the area of the second half period zone. Okay. So to find out the second half period zone, this is O M2, okay, which is nothing but R2. So this is O M2 and this is point P, okay, and this is P plus 2 lambda by 2. Okay, first one B plus lambda by 2, second one 2 lambda by 2. Okay, so this 2 will get cancelled. So B plus lambda. Okay, so I will use again. I want to find R2. So R2 square equal to hypotenuse square minus base square. So that is B plus lambda whole square minus B square. Okay. So R2 equal to if you expand that one, you will get root 2b lambda. Okay. So this is the radius of the second half period zone. So here I forgot to tell you one thing. See the distance from the point P to different half period zones. So from P to M1, okay, that is the distance is B plus lambda by 2. Some P to M2, B plus 2 lambda by 2. P to M3, B plus 3 lambda by 2. Similarly, if I want to get P to Mn, Mn is the nth half period zone, that will be like B plus N lambda by 2. Okay. If I ask you what is the distance from the P to M6, M6 means 6th zone, what you will write? B plus 6 lambda by 2. If I ask you 10th zone, P to M10, then you will write B plus 10 lambda by 2. Just you add B plus lambda by 2, which is how many first, second, or third, that you just add, go keep on adding. Okay. So I found out the radius of the first half period zone and radius of the second half period zone. Now it's time to find out the area of the second half period zone. Area of the second half period zone, if you see in this diagram, so this is the area of the first half period zone. So this is the first area of the first half period zone. What will be the area of the second half period zone? Is it complete thing? No. So this portion only, shaded region. Okay. So that means you have to subtract. Okay, this is the only area of the second half period zone. Similarly, third half period zone area will be only between M2 and M3. So that's why I am using here this formula here to find out the pi into OM2 square. OM2 square means this one, radius of the second zone. O2 M2 square. Okay, pi R2 square minus pi R1 square. Okay, that is the formula I am just using. So pi R2 square is the complete radius of the M2. Okay, but I want to only get the shaded region, so I am just doing pi R1 square. Okay, pi R1 square. So R2 square value we just now found that pi into 2b lambda, right? Pi into R1 square lo just b lambda. Okay, b lambda. So what you will get? Pi b lambda. Okay, 2 pi b lambda minus pi b lambda, you will get pi b lambda. Area of the second half period zone also you are getting pi b lambda. You see, first half period zone area is also pi b lambda, second half period zone also pi b lambda. So what happens to the nth half period zone area? It will also be pi b lambda. So area of any period, any half period zone, any half period zone, half period zone will be pi b lambda only. Okay, so this is independent of the number of the zones, like first zone, second zone, third zone, fourth zone, fifth zone. All zones will have the same area. Okay, they will not depend upon the number of period zones. So area of the all the zones will be same, pi b lambda only. So what happens to the radius? Radius is you will get the square root of root n b lambda. So radius of the first zone root b lambda, radius of the second zone root 2b lambda, radius of the third zone root 3 lambda. Similarly, radius of the nth zone will be root n b lambda. Okay. So radius is directly proportional to the square root of the natural number. So if I want to get the radius of the 10th of period zone, it will be square root of 10 b lambda. If I want to get 20th of period zone radius, then square root of 20 b lambda. Similarly, what will be the area of the 20th zone period? It will be always pi b lambda. Any of period zone time period area will be pi b lambda only. So areas of the zone depend upon only lambda. Okay, only. So they depend upon only wavelength of the light and also how far from the point P. Okay, this planar wavefront is at a distance point P, right? So which is at a distance B. So area depends upon only these two factors. Area of the zone increases with increase in the wavelength of the light. If you increase the wavelength of the light, area automatically increases. Similarly, if you increase the distance from the wavefront, so you keep the zone at very far distances. This is one point, this is very far point. As you are increasing the distance, area also increases. Okay, so now I want to find what is the intensity at point P due to the Fresnels of period zone. There are Fresnels of period zones. The secondary waves are coming from these Fresnels of period zones. How much intensity they will what is the intensity at point P due to these Fresnels of period. So that's I am going to discuss now. So coming to the intensity, to find out intensity, intensity factor depends upon the mostly 3 points. Okay, what are those 3 points is, so this is a wavefront. Okay, on this there are circular zones, Fresnels of period zones. Okay, point P. Okay, first point intensity depends on different factors. Means first how much distance it is from the planar wavefront. That is the one point it will depend. And what is the area of the zone? It will also depend upon the area intensity. And obliquity factor. That means from point P, how much angle they are at. Okay, obliquity means some angle factor. So what are the angle from the point P, obliquity factor? So these are the 3 points which intensity depends upon at point P. Okay, so how much it is from the planar wavefront and what is the area of the zone, and obliquity factor means how much angle they are making. Okay, so secondary waves reaching at point P are continuously out of phase and in phase with reference to the central or first half period zone. This is very important point. Okay. First thing, as I said, the Fresnel off period zones will have a phase difference. First zone to second zone difference. Path difference will be lambda by 2. Similarly, phase will be pi. So, waves coming from the first zone and second zone, they always have a out of phase. Okay. Let's take center. Center means first zone is the reference. Okay, let's say from first zone whatever waves are coming, the second zone whatever waves are coming, they will be out of phase. Similarly, now the third zone nunchi, third zone, if you consider regarding the first zone, third zone and first zone will be in phase. Okay, alternative zones are will be out of phase, alternative zones will be in phase. Like first zone to compare cheste, second zone will have a out of phase, and third zone will be having in phase with the first zone. Similarly, fourth zone, whatever the waves coming from the fourth zone will have a out of phase with the first zone. Similarly, for fifth zone will be in phase with the first phase. So this point is very important. If you don't get this point, you will not understand the next coming steps. Okay, so first zone, second zone will be out of phase, and first zone, third zone will be in phase. Okay, odd zones will be in phase, let's say. Even zones will be out of phase as compared to the first off period zone. Okay, and whatever the waves coming from the first zone, uh, first zone, yeah. So the waves coming from the first zone is m1, which is whose amplitude is m1. Okay, first waves coming from the first zone whose amplitude is m1. Similarly, waves coming from the second zone, you see here I am keeping the downward arrow. That means out of phase. Okay, out of phase. And upward arrow means in phase. The third zone amplitude wave is M3, which is in phase with the first zone. Similarly, M4 is out of phase with respect to the first zone. M5 is in phase with the M1. Okay. Similarly, M6 is out of phase. So all odd zones will be in phase, and all even zones will be out of phase with respect to the first half period. And also one thing you should consider here. You see the amplitude keep on reducing. Amplitude values M1 is very much greater than M2. Okay, M2 is much greater than M3, M3 much greater than M4. So amplitude keep on decreasing, and also obliquity is increasing. You see the angle made by that one. Okay, so these points. So as we consider zones, when you are going out of from the O, obliquity increasing. Okay, and also amplitude is keep on decreasing. Keep on decreasing amplitude. So M1 is slightly greater than M2, M3, so on. As I said, M1 greater than M2, greater than M3, greater than M4. So due to the phase difference pi between any two consecutive zones, if the displacement of particles due to the odd numbered zones is positive, then due to the even numbered zones will be. So what he is saying that if if you consider odd numbered zones are always positive, and you consider even number zones always a negative. Okay, so here one more thing is, since m1 greater than m2 greater than m3, they follow arithmetic progression. M1 greater than M2 greater than M3. They follow arithmetic progression. In this arithmetic progression, if I want to get the middle value M2, there are three values M1, M2, M3, and they said they are following the arithmetic progression. I want to find the M2. How do you find? M2 is the average of the other two numbers, M1 plus M3 by 2. So this is arithmetic progression condition. Okay, to find out the middle value, it will be the mean of the amplitudes due to the zones preceding and second. So this is the point I am writing here. M2 can be written as M1 plus M3 by 2 since they are following arithmetic progression. Okay, similarly, if I give you M3, M4, M4, M5. Okay, I want to find M4. How you will do? M4 equal to M3 plus M5 by 2. Okay, so I will use those steps in the next one. So the resultant amplitude at point P. So due to the Fresnels of period zone at point P, okay, due to the first zone, second zone, third zone, the next amplitude, resultant amplitude at point P will be, why I am finding amplitude? If you know the amplitude, you can easily find out intensity. So due to this Fresnel of period zone, due to this Fresnel of period zone, due to this Fresnel of period zone, what is the amplitude? So I will write net amplitude equal to, due to the first zone M1, okay, I told you all the odd zones will be positive, all the even zones will be negative. So M2 means even zone minus M2 plus M3 minus M4 plus M5 and so on. Okay, and so on plus Mn if it is odd number. Last one is odd number, then it will be plus Mn. Otherwise, it will be minus Mn. If it is a even number, you will keep a minus. Okay. So area, this term I will just uh, rearrange this term. Okay, you see how I am doing this one. uh, so m1 can be written as m1 plus m by 2 plus m1 by 2. Okay, so I am just dividing m1 term here into two terms, m1 by 2 plus m1 by, so keep the bracket here, m1 by 2 minus m2. Similarly, all odd terms will be divided like this, m3 by 2, m3 by 2. Similarly, m5 by 2, m5 by 2. All odd terms will be divided. Only even terms will be left it like that. Only odd terms will be divided into two terms. Okay, since earlier I said they follow arithmetic progression, so m2 can be written as m1 plus m3 by 2. Okay, similarly m4 can be written as m3 plus m5 by 5. So you see m3 plus m5 by 2 already it came, minus m3 plus m5 by 2. So it will be, this term will be 0, this term will be 0. So only left out with the final term, there will be mn by 2, right? So you will get only this term. ఇక్కడ m1 by 2 plus m3 by 2 minus of again m1 by 2 minus m3 by 2. So this term completely 0, this term completely 0. Finally, you will left out with this term, a is equal to m1 by 2 plus mn by 2 if it is odd. If it is even, you will have this term. Okay. So if the whole wavefront is unobstructed, means complete wavefront is transparent. Okay, then number of off period zones that can be constructed with reference to the point is infinite. Infinite zones you can construct. So last terms usually will be 0 because amplitude of the first zone is very much greater than second zone. Okay, So for nth zone యొక్క so amplitude of the first of m1, okay, if you keep on going infinite terms, the amplitude term of the last term will be very very small. It's almost like zero. So only the major contribution from the Fresnel's off period zone, when whole wavefront is unobstructed, that means it is transparent, then only the amplitude at point B due to complete wavefront is this is okay. So you remember amplitude of the wave at point P. So this is planar wavefront at point P. The amplitude of the wave due to complete wave, whole wavefront is m1 by 2. So first zone నుంచి వచ్చిన amplitude major role. Okay, so if you know the amplitude, you will find out the intensity formula, square of the amplitude, that means m1 square by 4. Okay, so this is what I have derived till now. So I have found radius, area of the Fresnel zones, and also what is the amplitude at point P due to the whole wavefront. It is m1 by 2. Only first zone will give you the major contribution and intensity. Okay, now it's time to know about zone plate. What is a zone plate? And uh, we discussed till now Fresnel's off period zones. Okay, so zone plate is something like a device. It uses to focus the light. If there is a light, if you want to focus, what kind of things you will use? You will use convex lenses also. Okay, so there is a source of light. I want to focus this light. Okay, so if you use the convex lens light something, you can go, if it is parallel beams coming, then they get focused at focal point. Okay, so due to convex lens, parallel beam can be focused at point P. Okay, so to focus light, we will use convex lens. Here convex lens using just a refraction phenomenon. So light is getting refracted and getting focused at point P. If you use curved mirror, something like you take a mirror means one side is coated, other side is reflecting. Okay, so light falls on that one, will get reflected back. Okay, so it will be focused at point. So here the phenomena is reflection. In mirror, the principle is reflection. In lenses, it is refraction process. Okay, refraction process. Whereas in zone plate, the main principle is diffraction phenomena. Okay, so this is the different from the, unlike lenses and curved mirror, the zone plate uses the diffraction phenomena to focus the light. Okay, zone plate means nothing but like center of rings. There will be zones. Okay, it's a set of radially symmetric rings known as Fresnel zones, which alternate between opaque and transparent. Like first zone ki second zone, if it is opaque portion, there will be transparent. So first zone will be transparent, second zone will be blocked, and third zone will be transparent, and fourth zone will be blocked. Opaque means it's not transparent to the light, it's a transparent. Okay, so such type of zones, radially symmetric rings which alternate zones, are opaque and transparent. Then light coming from the zone plate will diffract around the opaque zones. So any light which is coming from the zones, they diffract at the opaque zone. Okay, so that's the phenomena zone plates are using. So when odd zones are kept transparent, so I will show you here one image. So coming to this one. So when odd zones are kept, actually here I have done a mistake. Okay, so here, this is a negative zone plate. This is positive zone plate. Positive zone plate, and there are two kinds of zone plates: positive zone plate, negative zone plate. What is main difference is positive means all odd zones are transparent. All odd zones are transparent. So I am once again drawing here. So this is, let's say, first zone, okay, which is transparent, and second zone, which is opaque portion. Through this you will not get any light. So ikkada actually first zone is the transparent. This is the transparent portion, okay, light is coming. And second zone is opaque, okay. Sorry, this is correct only, positive zone plate, this is negative zone plate. So first zone is transparent, second zone is opaque portion, which is completely block, it is written in black ink, okay. Third zone is transparent again. Fourth zone is completely blocked, it's a opaque portion. So all odd zones are transparent, all even zones are opaque portion. Such kind of plate is called positive zone plate. This is a positive zone plate. Now negative zone plate, opposite. So all odd zones are opaque and all even zones are transparent. You see, first zone is completely opaque, second zone is transparent, third zone is opaque, fourth zone is transparent, okay. So this is even negative zone plate. So positive zone plate, negative zone plate. uh, so all so radius of the zone plate is proportional to the square root of n, okay. So this is all about the zone plate. If you consider this one, you see the complete wavefront. Here the planar wavefront is divided into the number of zones. All zones are transparent, okay. Here all zones are transparent, no one is blocked. So amplitude at point P will be it will be, so amplitude will be, as the last class I told you, m1 by 2, due to complete wavefront to due to the complete wavefront, the amplitude at point P will be m1 by 2, okay. So m1 will be 2a. So intensity will be a square. So that means m1 square by 4. Okay. So this is the intensity you are getting due to the complete wavefront. Let's say due to the odd zone or even zone, what will be the amplitude and what will be the intensity at point P? Will it be the same as this one, or will it be less than this one? Will it be more than this one? Okay. So positive zone plate means odd zones are transparent. So first zone is transparent, second zone is blocked, third zone is transparent, fourth zone is blocked, all even zones will be blocked. So only light coming from the odd zones. So m1 is due to the first zone. Since all odd zones are positive, so m3 is the third zone amplitude. So all will be something like, you in just considering only 20th zones, there are only 20 zones, so you will get up to 90, okay. So total value will be something like 10 m1, okay. All zones will have the same amplitude, so you will get 10 times of the amplitude of the m1, because 10 times will be there. So sorry, yes, 10 m1, yeah. So 10 m1 will be here. Since m1 is equal to 2a, substitute that one here. So a naught will be 20 times of the a. So ఇక్కడ ఉన్న value m1 is equal to 2a ని ఇక్కడ substitute చేస్తాను. So you will get a naught is equal to 20 times of the a. So intensity will be 400 times to the amplitude square. You see very big difference is due to the complete planar wavefront. If it is transparent, and at this point you will only get the amplitude as a square, 1a square, okay. But due to the odd zones, you are getting almost like 400 times to the a square. So much intensity at point P, so it will be so much bright as compared to the complete planar wavefront. So that's why odd zones, a positive zone plate and even zone plate will give you the more intensity as compared to the complete planar wavefront, okay. So they will be useful to generate a bright light. So now, okay, I will stop it here. Next class, I will tell you how to construct and working of the zone plate. Okay, thank you very much.